Okay, so we're going to be doing 3.1, ready, set, go for number 10 and number 14. So it says for problems 10 through 12, the recursive rule for the polynomial function is given in this form. Next equals previous plus rate of change. This is very standard. If you're not comfortable with this yet, just kind of get used to seeing this over and over again, okay? So the way I got to the next number is I'm just adding whatever number, whatever rate of change that they did. So here's number 10. You can kind of already pick off what your rate of change is, okay? Then it says use a recursive rule to fill in the 5 values of the table, and then it says identify the rate of change and then classify the type of polynomial that's it's either linear, quadratic, cubic, and then use the differences in the table to check your answer. Okay, so I'm not going to do this in order because this order, it doesn't make sense to me, right? So it says f of 1 equals 10. So if you don't know what that means, it basically means when x is 1, then y is 10. So I'm going to put a 10 in here. That's the first thing that they told me. So I'm going to put a 10 right here. And then they told me next equals previous plus 7. Next, the next number that I'm going to put on here is equal to the previous number plus 7. So if I want to find the second guy, I'm going to look at this 10 and add 7 to it. Yes. So I'm going to add 7 to it. And so that number becomes 17. Okay. And then because I'm here, I might as well fill in the rest of this table. So that plus 7, plus 7, plus 7. And some of you are already like, oh, I know what kind of function this is, Miss Johnson, because of blah, blah, blah. Good. Keep going. So I think this is 24. And then it's, I think, 31, and then it's 38. Okay. So just be patient on that as it shows up. Okay. So then it says, okay, so I filled in all the table. I did that. Identify the rate of change. I could have done that in the very beginning. So here, if you look here, it tells you f of n minus 1. Do you kind of see matching f of n, f of n, f of n minus 1, f of n minus 1, plus rate of change is literally 7. He's literally sitting in that spot. So I'm going to write my rate of change as plus 7. Ms. Johnson, why did you put plus? Because I wanted you to know that I'm adding 7. I'm not multiplying 7, subtracting 7. I want it to be very clear. It's plus 7. See, that's what I put down here. So it's plus 7. Then it says classify the type of polynomial. Well, you all learned a little bit ago. It's going to show up here, I promise. You all learned a little bit ago when the first set of differences is exactly the same. Awesome. It was exactly the same. What kind of function does that make this? When it's exactly the same? Well, we wrote over here. Let me see if I could still grab that. Let's see. Yeah, it's right here. No, it's not here. It's right here. Haha. So it says, because the first set of differences aren't the same, we know it's not linear. So if they are the same, it's linear. So I'm going to say that again. Because these were different, we knew it was not linear. Because this one, our first set of differences, is all the same, we know that it's linear. So I'm going to write linear here. And I'm going to point to this because these are all the same. I'm going to highlight them. When I highlight them, I hope you get, because these are all the same, then it's linear. Okay. And then it says use the differences in the table to check your answer. So I think they were assuming that you would plug it in here. If you wanted to, you can plug it in. I'm just going to pick a random number like f of 4. So if I'm going to check f of 4, it would kind of look like this. Let me scoot this over. If I check f of 4, oops, this is me checking. F of 4 is equal to, now I'm plugging it in right here, right? So it says f of 4 minus 1 plus 7. Okay, well, what's 4 minus 1? Well, that's 3. So f of 3 plus 7. okay, well, where do I find f of 3? Well, f of 3 is the output when the input is 3. So you want me to put a 24 there? Yeah. So I'm going to highlight this so that you guys all see this guy here is this guy here. So I'm going to put 24 there instead. And then I'm going to add my 7 to it. And I'm hoping that 24 plus 7 is the same as this guy. That's what I'm hoping for. So 24 plus 7 is in fact 31. So then because this guy matches this guy, Miss Johnson is happy. Why is she happy? Because I did my work right. And that means that I can't get any points marked off, right? So I'm going to walk this through one more time just so we're on the same page. So the first thing that you have to be comfortable with is knowing what this actually says and translating it into your brain. So f of 1 equals to 10 means 1 comma 10. This right here means in order to find the next term, you look at the previous term and you just add 7. And I'm like, oh, okay, so add 7, 17, add 7, 24, add 7, 31, add 7, 38. And as long as I'm adding correctly, most likely these will all be right. Okay, the next thing they said is identify the rate of change. Up here, they told you that this guy here, hanging off the end after f of n equals f of n minus 1 plus rate of change. So I noticed that is exactly the same form that they gave it to me. So this guy must be my rate of change, which makes sense because that's the rate of change that I used here. Ta-da. Okay, and then it says identify the polynomial, and I'll just refer you back to this chart over here. So the first set of difference is it's linear to the first, right? The second set of differences, well, that's to the power of 2, quadratic. Third set would be cubic, which then brings me down to your exit ticket of what you all were supposed to talk about. What would that say about the fifth set of differences? What would that say about the fifth set of differences, right? Okay, so hopefully that makes sense. That's number 10. Someone else requested number 14, so I'm going to do that. Number 14, the directions are up here. Find the rate of change. 1, find the rate of change. 2, write the recursive function. So if it's constant, if the rate of change is a function, write the equation of the function. Okay, fine. And then identify the type of function. Okay, so here, they want me to find these 3 things. So I can do that real quick. So the first thing I'm going to do is I'm going to look for my first set of differences because that tells me a lot. So I'm going to go in here. And when I'm looking for my differences, I do bottom minus top. So I go 1 minus 6, that's -5. Okay. And then I do it again, -4 minus 1, oh, that's -5. And then you're like, oh, Ms. Johnson, I already know what it is. Really? You know what it is? Okay. Before you say you know what it is, just kind of go through a couple more just in case. Okay. So -9 minus -4, still -5. And I still get -5 and I still get -5. So the rate of change right now is -5. My type of function, oh, it's not catching up to me. Let's see if I can get this guy to catch up. There it goes. So the rate of change is this guy, -5, because you see -5, -5, -5, -5, -5. That's my rate of change, -5. My recursive rule, I'm going to skip for just a second. And my type of function, well, because these are all the same, you all know, oh, Ms. Johnson, it's linear. First set of differences, meaning it's the answer is going to be x to the first. Okay, your recursive rule going back up here is labeled in 2 parts. Your first and then the actual rule. Your first and then the actual rule. So I need to say f of 1 equals 2. Well, what's f of 1 equals 2? What is f of 1 equals 2? Okay, f of 1 is 6. That's right. Okay, so then that's the first part of the rule. Okay, and then this is going to catch up. So f of 1 is 6. Now we need to find the rest of the rule. So the rest of the rule is going to take on that structure. F of n equals f of n minus 1 plus rate of change. Okay, so then now what I'm looking for is, oh, it's not catching up to you. Hold on a second. Okay, still not catching up. Let me just type it over here in case I don't get it. So f of n, oh, actually, let me just snip it because that's faster. Let me grab this guy right here. Let's see this. Let's see this. Let me grab this right here. Okay, so I'm going to copy this right onto our page because that's exactly what I want. I want this. Oh, now it shows up. Of course. Okay, so instead of rate of change here, I'm going to actually plug my rate of change in, right? So I'm going to have this be -5 here, but the rest of it's going to be exactly the same. F of n equals to f of n minus 1, and then this -5. And so that's my function, my recursive rule. Your recursive rule is always going to have two parts to it, a starting point and how you get to your next point. Okay, so review really quick. You're still looking for your differences. In this case, because my rate of change, -5, -5, -5, -5, -5, that's my rate of change. Because they were all the same on the first, set of differences, that makes it linear, which makes writing my recursive rule relatively straightforward. You write the first term, f of 1 equals to 6. And then you write this structure, and then you just plug in your rate of change. In this case, it's just f minus 5. Got it?